Good morning, class, and welcome to this lesson on Kinematics 9 velocity time graphs. We will be able to relate velocity time to position time graphs and describe acceleration. Okay, so we're going to now take our position time graphs and relate them to velocity time graphs. So here we go. Let's go back to our original position time graph, x, t. If an object was standing still, it would have a straight line. It has a fixed position. Okay, it has a fixed position. So if I drew a velocity time graph, so now I'm measuring velocity. So x is in meters, time is in seconds, that doesn't change. Time is in seconds, velocity is in meters per second squared. If I had to make a graph based off this one, what would it be? Well, if an object is not moving, its velocity is 0 meters per second. So it would just be a straight line right on the x-axis here. I'm going to make it really thick so that way you can see it. So it would just be a straight line right on the x-axis. It's not moving. Okay, so that's our first one. That was our first example. Let's take this one now. Let's go. An object is moving at constant velocity. An object is moving at constant velocity. So this is a positive sloping line. This is a positive sloping line. So if my velocity is constant, if I have constant velocity, let's say this is, 2 meters per second here, it's going to be a straight line. So a sloped line on a position time graph is a straight line in a velocity time graph. Okay? And vice versa, if I had a negative sloping line, excuse me, if I had a negative sloping line, I would have a constant negative velocity. I would have a constant negative velocity. So as you can see here, here's three very common situations. X standing still is 0 velocity. Positive constant velocity is a straight line in a velocity time graph, and negative constant velocity on a position time graph is a straight line on a velocity graph, okay? So those are the three basic ones. So let's look at some more situations here, okay? Let's look at some more situations. We're going back to a position time graph now, a position time graph. Notice this is a curved line. We haven't covered that yet. This is a curved line. So a curved line in a position time graph means the slope is constantly changing. The slope here, I'll do red line just to be clear. The slope here would be 0. The slope here would be a little bit more. The slope here would be a little bit more. So notice the slope is constantly changing. The slope of this line is constantly changing. Or in other words, if the slope is changing, that means velocity is changing. And what do we know about changing velocity? Changing velocity means acceleration. So let's start us from the very beginning here. Let's do a, come on, a position time graph just like this one. Position time. This slope is changing. And we'll say it's changing at a constant rate. Is changing at a constant rate. So the velocity is slowly increasing. So the velocity is slowly increasing at a constant rate. So a curved line on position time is going to equal a straight line on velocity time. And the slope of this line is constant. What is acceleration? Acceleration is velocity over time, the change in velocity over the change in time. So the acceleration here is the change in v over the change in t. That is equal to the slope of this line. Notice it is a constant slope. So if we did an acceleration time graph, we would have a positive straight line. So a positive position time would equal a straight sloped velocity time, which would equal a straight constant acceleration time. Okay? And vice versa, if we have a position time graph that was decreasing, the curve down, position time. This means the velocity, they had a very high velocity, and the velocity is getting smaller. So velocity time is going to be going down, and that means acceleration is a constant negative acceleration. So acceleration will be a constant line in the negative arena here. Okay. And I want to point out a couple things about these graphs right here. Okay. Notice here the velocity is about to cross the origin, right? The velocity is about to cross the origin right there. When the velocity crosses the origin, when the velocity, that means that this object is stopped. That means this object is stopped. That means at 0 meters per second, okay? It did not return to starting position. When the x graph, I'm just going to continue this down. When the x graph crosses the origin, that means it returned back to the origin. It returned back to position 0, okay? But when the velocity crosses the origin, that just means it stopped for a moment, okay? So notice here, this point right here, where the slope is equal to 0, is the same point right here where velocity equals to 0. Okay, so what I'm going to do now is I am going to go through and I'm going to give you the whole gamut. Okay, so here we go. See if I can do this on one page here. Okay, here's position, time, here's velocity, time. Okay, let's say we have an object, I'm going to do different colors here, that is accelerating. It stops. It is then going to curve up like this, stop. It's going to curve back down, stop, and then it's going to do this. Okay. Okay, so this part right here, this is an object accelerating. This is an object accelerating, and so the velocity is constantly going to increase. So we're going to have a straight line moving up. Now here, the velocity is decreasing until it reaches 0. The velocity is decreasing until it reaches 0. So we're going to just decrease here until we reach 0. The velocity is going to increase in magnitude, but it's still going to accelerate, and it's still going to go in the negative direction here. So notice here, the slope is now going to be getting larger, but it's getting larger in the negative direction. So it's going to be larger in number, but still in the negative direction. And then right here, it's going to be decreasing in magnitude, but increasing until it reaches 0 again. This point right here, velocity is equal to 0, and this point right here, velocity is equal to 0. So 0 and 0 are both right there. So you can kind of see here, increasing velocity, decreasing velocity, increasing velocity in the negative direction, decreasing velocity in the positive direction. So if we were going to do a acceleration time graph, acceleration time, this is a positive slope, so it would be positive. I'll do the colors again. It would be positive. Okay. Then it would be constant negative. And then that doesn't change, constant negative. And then we do purple again, it will go back up and be constant positive. So we have positive acceleration, negative acceleration, negative acceleration, positive acceleration. So I'm just trying to get you to see how all these graphs kind of relate together. So that should give you a good starting point for any graph questions you have in the near future.